So this lesson's on transforming quadratic functions. We want to figure out how does changing the coefficients of a quadratic function change the appearance of its graph. You may remember that we had done this earlier with our absolute value functions. So you might see some similarities here. You might remember some things, and that's going to be great. So we start with this idea that y equals x squared is a parent function. What I mean by the parent function is that every single graph we make comes from transforming this graph y equals x squared. So all the other graphs are like the children of this parent graph. A couple of the things about it. First of all, let's talk about the axis of symmetry. It's the line that cuts the parabola in half. In this case, it's the equation x equals 0. It's the y-axis. The next thing we want to talk about is the vertex. The vertex is the turning point. The coordinates of its turning point. In this case, it's going to be at 0, 0. It also tells us if it's a maximum or a minimum value. In this case, the minimum value of the function is y equals 0. All the other y values are greater than 0. The roots, where the graph crosses the x-axis. The roots of this graph are at x equals 0. The graph only touches at 0. And likewise, its y-intercept is also at 0. We might have other y-intercepts later on, but for right now, this one is at 0. So what I'd like you to do is to make sure you have your calculator ready. If you need to pause the video, do so. And then take your calculator out, and let's make these 4 graphs. Hit pause, sketch those graphs, and then we'll come back and talk. Okay, let's see. Did your graphs look like these? Hopefully it did. So you might notice that we started with the x squared graph. And your x squared graph was this one right here. When you graphed your next one, y equals 2x squared, did you find that the graph went in here? When you graphed your third one, your graph appeared a little bit wider, perhaps. In our last one, looks like it flipped over the axis. So there's a couple questions for you to answer. What happens to the graph of y equals x squared as the a value changes? So did you find that when a was greater than 1, the graph became more narrow? And when a was between 0 and 1, the graph became wider. And also that when a was negative, the graph flipped over. Those are some good transformations to remember. Well, let's keep going. Let's go back to our calculator. Let's start up a new graph. Again, graph y equals x squared. We're always comparing to that one. And then graph these two. Hit pause, sketch your graphs, and then we'll talk. So let's see what those graphs look like. Again, our graph y equals x squared. That's our blue one. Then the graph of y equals the square of x plus 1. This one right here. And what you might remember from earlier was that we can really write this as x minus -1 squared. And because we could write it that way, it's x subtract the x value of the vertex. So that's why our vertex moves to the left 1. For this green one here, we have that graph as well. So this tells us that's x subtract the value 3. So 3, positive 3, is the coordinates, is the x coordinate of the vertex. That's why we move to the right 3. So you might remember that it's really x subtract the h value. That's something pretty good to think about, is that when we graph it, we really call it x minus h. So a couple questions for you. What happens to the graph of y equals x squared as the h value changes? So what you probably found is that when your h value is less than 0 and your equation becomes, in parentheses, x plus h, that it went to the left h units. And likewise, when the h value was greater than 0, and in parentheses you got an x minus h, that it went to the right h units. Good things to work through. So we got one more to take a look at. Again, let's do another control N, new graph, graph y equals x squared, and these two functions as well. Hit pause, and come back in a minute. Okay, check out these graphs. Did they match yours? Again, we got our original graph, y equals x squared. There's our original. Then we graphed y equals x squared plus 2. Did you notice that the graph changed by going up 2 from the blue one? And likewise, x squared minus 3. Could you tell that the vertex went down 3 units? So another question for you. What happens to the graph of y equals x squared as the k value changes? The k value meaning that we have y equals x squared plus k. So did you find that when k was greater than 0, that our graph went up k units? And likewise, when k was less than 0, it went down k units. So what I recommend you do is create a summary of everything. Describe all the different changes that could occur to a, h, and k. How does the graph change when we change those numbers? Take a moment. See what you can write down. Hit pause, and then come back when you wrote them all out. All right, if you went back through your notes, you probably realized that when a was greater than 1, it became more narrow. And between 0 and 1, it became wider. And when it was less than 0, it was a flip. You might remember that when we had something in parentheses like x plus h, it was really x subtract negative h. So that went to the left. And then x subtract h, that subtraction sign tells me that my h value was positive here, and I'm going to the right. And finally, when k is greater than 0, we go up. And when k is less than 0, we go down. How'd you do on those? I hope well. Let's put it to the test. What I'd like you to do is stop the video and do this problem. Alrighty, so did you remember that the negative made the graph flip? And that the 2 makes the graph more narrow? And that because it's x plus 5, that means it's really x subtract negative 5, so it goes to the left 5. And likewise, the negative 3 meant that it goes down 3. Very good. That's also going to tell us our vertex, because we're taking the vertex and all the other points, moving them to the left 5 and down 3. So our vertex is going to be at the point negative 5, negative 3. So if we take our graph y equals x squared, we know it's going to look something like a parabola like that. That's y equals x squared. What's our new graph going to look like? Well, we got to flip it make it more narrow, move it to the left 5 and down 3. So maybe that's to the left 5 and down 3. And our graph looks like that. Check it in your calculator. See if you're correct. Hopefully, based on this, you can understand how the different coefficients change the graph of y equals x squared.